Welcome back, everybody. This is part 2 of 3 in my lecture series on solving other kinds of equations besides quadratic ones. In the previous video, we looked at how to solve polynomial equations that maybe weren't quadratic. If you haven't seen that video, please go take a look at it now, as that information is going to appear in this video. In this one, we're going to learn how to solve radical equations. Those are equations where radicals show up. Let's get started. Like I mentioned in the intro to this video, a radical equation is just any equation where part of it is under a radical. Like in this first one, we're being asked to solve the square root of 6x plus 1 equal to x minus 1 for x. Now, the thing about radical equations that are tricky are the radicals. So we just get rid of them. That's kind of the only trick there is to it. The inverse operation to a square root, if you recall, is the square. So I'm going to square both sides of the equation. And notice I put parentheses around the other side. That is because what I do to one side of the equation, I have to do to the entire other side. So because I'm squaring the left side, I need to square the whole right side. On the left side, that's just going to cancel out my radical. And I'm going to be left with 6x plus 1. On the right side, remember this is not x squared minus 1 squared. This is x minus 1 times itself. So FOILing those terms out, I get x squared minus x plus 1. Combining my like terms on the right-hand side, that gives me x squared minus 2x plus 1. And now I have a polynomial equation. See if you can pause the video here and finish solving this problem. The answer that I found was x equals 0 and 8. From this point, remember, I need to first move all my terms over to one side. I move them to the right side. Then I need to factor. And then I need to use the zero product property to get my solutions. You're welcome to pause the video here to check over my work. Otherwise, let's move on to another one. This problem has an added difficulty, being that I've got two radicals. The process is still the same, though. To get rid of the radicals, I'm going to want to square both sides. See if you can pause the video here to try this one on your own. Oh, it was a bit of a process to get there. The answers that I came up with were -1 and -2. Let's see how the two radicals make this problem a little bit more challenging. Notice when I FOIL out that left-hand side, I still have a radical equation left over. But that doesn't mean we need to give up hope. I can move all of my not radical terms over to one side, and that leaves me with the square root of x plus 2 times 3x plus 7 is equal to -2x minus 4. From here, this is a radical equation that looks like the previous one that we solved. So I just square both sides. And that leaves me with a polynomial equation that ends up giving me the solutions -1 and -2. I'm going to zoom out on this problem so that you can pause the video here to look over my work a little longer if you need to. Otherwise, I've got one last problem for us to try. Now, even though it doesn't look like it necessarily, this is still a radical equation, because if you recall, those rational exponents are really radicals. Under the hood, and I'm going to put this in a little thought bubble here, this is x plus 3, remember the numerator stays as the exponent, and the denominator becomes the index of the radical. So this is really the cubed root of x plus 3 squared. So far we've only looked at square roots, not other kinds of roots. So how do we tackle it? Well, In the previous problems, to cancel out the square roots, we raised both sides to a power that would cancel it out. In the previous problems, remember, we had, stuff to the 1/2 power, and the way that we canceled that out was by raising the whole thing to the 2nd power. Remember, when I have a power to a power, I multiply those powers together? So I got stuff to the 1/2 times 2, or 1 power, and that canceled the radical out. The idea with this problem, and why don't I extend my thought bubble here? The idea with this problem is the same. It's just that 2 isn't going to be the magic number that cancels out our radical. It's going to be the reciprocal of whatever this number is. So we need the reciprocal. Remember, that's the fancy word for flip it over. So in this case, I want to take both sides of my equation and raise it to the 3/2 power. To the 3/2 power. Same thing on the right-hand side. Remember, what I do to one side, I have to do to the other to make sure I get the same solution set. Now, my 3/2 and 2/3 multiply to get me 1, and I'm just left with x plus 3 on the left-hand side. On the right-hand side, remember, 4 to the 3/2 power is really the square root of 4 cubed. Square root of 4 is, of course, 2 to the 3rd power, which is 8. So the right-hand side simplifies to 8. And now I have a pretty simple problem to solve. I just need to subtract the 3 over, and I get x equals 5 as my final answer. In this video, we saw how to solve radical equations. The trick being to use whatever the reciprocal of that power is on both sides, and that often clears our radical. Sometimes, like in the second example we saw, we need to do that process multiple times before all the radicals are cleared. In the next video, we're going to take a look at how to solve equations using a totally different method. Catch y'all in the next one.